Alright, Scrub Nation, for some reason your original video didn't work, so I'm having to recreate it. So let's just hope that the second version can be as magnificent as that first version was. Also, I'm eating, so you're going to have to work through the chew just a little bit. Alright, so in 5.1, we moved from polynomials to rational functions. They call them rational because rational means fraction. You see the fraction going on there. And a rational function is specifically a fraction where numerators and denominators are both polynomials. So our work with polynomials is going to come in handy here. Alright. Yesterday, you had to do x and y intercepts. Okay. I'm going to do that right now just to kind of review and cement that, being as that is our second quiz tomorrow, and give you an opportunity to ask any questions you've got on 5.1. But that's not what you're doing today. Today's only the vertical asymptote part, and I will also show you that as we get there in a second. So let's see. Y-intercept. Still, it's simply a matter of plugging in 0 for x. And this is where I stop and go, okay, with rational functions, before I get to doing anything else, and you're going, well, wait a minute, you just did get to doing something else. And I'm saying, well, yeah, but that reminded me that when I do these problems, I don't like to get to something else before I start off every time, always, by factoring top and bottom on these things, okay? And I'll explain why in a minute. So, rational function, got to be a ninja with the sequence now. No common term, two terms, that's not a difference of squares or cubes, nor a sum of cubes, so it is what it is. Okay, bottom, no common term, two terms, difference of squares, plus 1, x minus 1. And there are, before you even get going, just look at what you're dealing with so you can see what you're going to be running into as you move forward, okay? Immediately, I look here and recognize that, oh, I am not going to be able to let x be -1, and I'm not going to be able to let x be 1, because if I were to do that, it would make the denominator 0, and we know that that is no bueno, okay? And when we're talking about drawing graphs of these types of functions, we're wanting to know what happens at those places where the x values make denominators zeros. What does that look like pictorially? And the first, so our discussion with that takes us into vertical asymptotes, which is what we're going to talk about here in a minute. So I've already gotten in the back of my head plus and minus 1, red alerts, booby traps. You got to watch out for those values, okay? And then, of course, if you want to, you can recognize that that and that are the same, and simplify this to 1 over x minus 1. Okay, so now notice then, when I go to do f of 0, I have 3 different versions to look at. In my opinion, the easiest one is right here, because that all zeroes out. But obviously, that's not bad to look at either. This was, I definitely would not look at, although it creates the same thing. And we see that if I plug 0 in for x's, I'm going to get a -1. And you see where on the graph I have a y-intercept at 0, -1. Okay, So now, what about the x-intercepts? So remember, same as it's always been, x-intercept is telling me that f of x, the y, is 0. And this is where we go up here and go, oh, well, y is a fraction. And fractions are only 0 when the numerator is 0. Now, the easiest version to look at this here is this last one, because that gives the argument, well, that would imply 1 equals 0, and what? That's not true. So that implies no x-intercept. Or, if you didn't see that, you could look at either of those two and you would say that implies that x plus 1 is 0, which would make x equal to negative 1. And then you have to remember, oh, but x is not allowed to be negative 1. And so your memory of this would lead you to this same conclusion. Okay? And we'll turn these blue just to emphasize where that 0 is coming from. If you look at this graph, you can see that this is not going to touch the x-axis. It's going to get closer and closer and closer and closer and never touch. You go, well, wait a minute, it looks like it's touching there. Yeah, that's a pixelation deal. But a true and accurate graph, which you can see the calculator gives you certain limitations, will allow this curve to go on up forever and ever and ever and ever and get closer and closer and closer and closer, but never touch. Okay? So that is a nice summary of what we did yesterday. Again, nothing that you have to do today, but I just wanted to kind of review and put that in perspective so you're ready, your quiz ready come tomorrow. Alright, so we got intercepts covered. Now let's talk about asymptotes. And here's the thing. There really isn't any work to be shown if you do this first step. If you write down the problem and factor it, all your work is done. Okay? And here is why. You're going back to these vertical asymptotes are going to occur. That's one of the things that happens pictorially, graphically, at an x value, at an east-west location that causes this denominator to go to 0. That's one of the possibilities. So here's the way it works. If an x value, say like for example 1 block east, turns the denominator 0, but it does not turn the numerator 0, notice that f of 1 would give us, if you look at the middle, 2 over 0. If you look at the last one, 1 over 0. It makes no difference which one you look at, because either way you're getting the 0 on the bottom, and either way you see that. The key to vertical asymptotes, numerator is not 0, denominator is. I feel like that deserves a red underline. We need some red emphasis. Okay. Numerator not 0, denominator is. And that's how you know that you've got a vertical asymptote at x equals 1. And that is this dotted line we have here. It's not an actual line, it's like a force field barrier that tells you that this curve is getting closer and closer and closer and closer but never touches, closer and closer and closer and closer and doesn't ever touch. very much like what's going on with the x-axis. That is a horizontal asymptote. More on that later. Okay, that's as simple as it is. Now, just like the equation of a vertical line is x equals a number, such is the equation of a vertical asymptote. All right, and we can go ahead and box that in. And I know what you're saying. You're saying, well, I can't see what's in the box. And I'm saying, dude, relax. You're like, well, I don't want a box in it. Well, what about purple? Now, will you relax? Do you feel the purple vibe? Okay. So that takes care of the +1 issue. Well, what about the -1 issue? Well, notice very similarly that if we are 1 block west instead of 1 block east, that is going to produce a 0 over 0. And if you're looking at this middle expression, or for that matter, if you look at the first expression, okay? So a couple things here. First off, when you get zeros in the top and in the bottom, that is when you're going to have, that is exactly the case, where you have what we call an open hole at x is -1. Okay, and that also is ready to box up and say, okay, we found our vertical asymptote, we found our open hole. Again, notice that you don't even have to show this part. All you have to do is look up here and go, oh, -1, 0 over 0, horizontal or open hole, +1, number over 0, vertical asymptote. Done. Okay, non-zero over 0, I should say. All right. Now, when you're looking for vertical asymptotes and open holes, I always go to this one. Because notice if you went here, it would look like you're getting 1 over -2. What's the problem? The problem is the 0 over 0 is the part you canceled out. Okay? So you have to look at this middle part and make sure that the 0 over 0 piece is not being overlooked because you canceled it. Okay? That should do it for today. Let's see if this video loads. Good luck. Talk to me if you got any questions. Stay warm.